Thank you, Michael, for the introduction. So, good afternoon, everyone. So today I am going to share with you about our research, ongoing research in different applications of causal AI in different industry. So it's also nice to be here with the causal AI community. So I'm from Constructor University in Bremen, in Germany. And today I will focus on some projects, ongoing projects that focus on the whole pipeline of causal AI and their application in several use cases in industry. So, first of all, I also would like to appreciate my team here. Also, one of them, which also part of BMW research team, Ishansh, will also join, also present his work. So basically, our background is not the computer science, but more like industrial engineering and management. So therefore, most of our research is driven by the problems in industry. For example, in supply chain, smart city, sustainability, energy management, and so on. So in terms of research spectra, actually we have just started to work on the causal AI for 1.5 years ago. Actually, we mostly dealt with knowledge representations, how to formalize knowledge into kind of knowledge graph, for example, and also conventional machine learning, and also explainable AI. Basically, we want to facilitate the decision-making in the industrial systems that contains of just giving information, prediction, run some simulation, and then so that the action can be derived from this prediction and simulations. So what are the characteristics of complex industrial systems? So, first of all, that in the complex industrial system, there are a lot of interconnectedness. Each of the components in the system are interconnected. So if there is one problem or one disruption, then it could propagate into or give a effect into different part of the system. For example, in the context of supply chain, so if you remember the accident of Ever Given, so that's a ship that stuck in the Suez Canal in 2021. So it caused some disruption in supply chain. For example, the container index price was rising because of the empty container and then some delays of the shipment and so on. So, and not just that the propagation of the effect goes everywhere, but the effect is also mostly non-linear. So that one small change can give huge impact in different fields. And again, so because of this, in the complex industrial system, that information flow is important. That means the information should be able to be consumed by the others, so it should be understandable, and also it should facilitate some kind of feedback loop so that the information that's come from one part can be interpreted by the other part, and also then some appropriate feedback can be given. Therefore, because of those characteristics in complex industrial systems, so a lot of requirements for the role of AI, which should be fulfilled, in this context. So if you see this some keywords here, the light blue ones are actually the ones that could be fulfilled mostly with the conventional machine learning, like accuracy, that it can handle a lot of large amount of data, and also robustness. But not all of the AI system can fulfill the ones that highlighted in the dark blue here. For example, lack of transparency and also explainability and interpretability. So, and also what's also already mentioned by this morning talk, Darko, said that also it should somehow consider ethic. For example, it's free for discriminations and so on. So the integration with existing system, for example, is not just that it can work technically, can be integrated technically in the system, but also can be accepted by human. So therefore, because human is part of the industrial system. So in today's talk, we will focus on 4 use cases. They are ongoing projects. First is about project management, how Causal AI can be used to optimize the software project management in this case, and then how Causal AI can help the policymaker in circular economy to increase the adoption of circular economy, and also to support the implementations of sustainable manufacturing. And at the end, Ishansh will elaborate more on the supply chain management. So what the common approach that we follow is actually also aligned with the system like developed is called DUI, so that we always first come up with the model, with the causal model. So the causal model here, we in one side we try to conduct some experiments using automatic causal discovery algorithm, and also we also integrate a domain expert to validate that, or even like if the result is quite off, then the domain expert can model from scratch. And then we identify the possible causal effect and estimate the magnitude of the causality at the end to validate the robustness of the model. So for example, in software project management, so one, we focus here in the risk assessment, how we can optimize the project management, we can assess the risk. And first of all, we need to identify what are the key indicators that represent that can measure the risk of software project. For example, like complexity or quality that can be derived into kind of quantity, for example, line of codes and so on. And we need to identify what are the potential contributing factors that contribute or affect that indicator, and at the end, how project manager can use the result to mitigate proactively how to optimize the project. So you can see on the left side here a result of Lingam for the automatic discovery of the causal discovery. And on the right side, you can see here like the expert or causal graph that modeled by the expert. So in this case, is quite well aligned, so that like the commuter experience and the task type and so on, and soft complexity metrics like average cyclomatic complexity number can affect the risk of project. In this case, is measured by total number of line of code. So there's some differences, but we could say that it's aligned. So that means in this case, the automatic causal discovery can help to as the helping or assist the expert in generating the graph. But in some other case, it's different. So some of the algorithm, because of different assumptions, for example, that's made in the algorithm, for example, and also the data, it results in some graph that off from the experts. So in this case, therefore, this is important always to keep in mind that human should be in center of this whole process. So the result after doing the approach, this loop that I show you, so that, for example, the first finding is that the developer experience, or in this case, the committer experience, play important roles in reducing the complexity of the software. For example, it can reduce the number of lines of code up to 161 lines, and also the communication among developers can also lead to changes of the code after the post main branch merge. So that means change after it's somehow finalized in the inside the team. So in this case, that means some derived action is that the project manager need to always include some people that is already experienced and also integrate some communication tools. So, and in the circular economy, we try to help policymakers in the European Union into developing some measure to increase the adoption of circular economy. Circular economy is the economy system that focuses on the reuse and recreating a product so that the product creation could be always continuous in like a loop. So to minimize the waste or to minimize the environmental impact. So in this case, with the similar approach, so in this case, we use the data from the World Bank and also from Eurostat. So here we found that this what do you call it? Circular material use rate is a good indicator to measure the adoption of circular economy on the macro level. So macro level, that means in the whole, on the country level. So, and we can identify here the different factors that influence the material use rate. For example, the waste collection coverage, compared to the waste that is not collected. So that means the percentage of the waste that is already collected, and also like the material flow. That means if a lot of material flowing in the system, in the supply chain, so that means its possibility to have more waste is higher. So you can see here some findings that we can get from the Causal AI, so if we increase the waste collection coverage by only 1%, it could result in substantial of increase of the circular material usage. That means the adoption of the material of the circular economy can be increased well. So therefore, some derived actions, like expanding the waste collection coverage, not only like the waste processing, but also in the collection, and also recycling, using more recycling materials should be encouraged. And the last, before I hand over to Ishansh, is in product development. For example, in the development of a car, which features of the car can impact CO2 emissions. So we also use some data, still ongoing. So we want to use the data from the European Environment Agency combined with some company data. So for example, here we identify some of the causal factors that influence the CO2 emissions, like the engine power and also engine capacity and so on. So there you can see here that different factors give different effect to CO2 emissions. For example, here that is quite significant in increasing the CO2 emissions is to increasing the engine power by 1 kilowatt. That means, in this case, the product or automotive developer need to reduce the engine power. So Ishansh will go into detail in one of the use case, which is in supply chain management. So I would like to hand over to Ishansh.
Just to round out that fourth use case then, to talk about the supply chain management, I'd like to introduce Ishansh Gupta, who is a lead data scientist at BMW. So thank you very much, Ishansh.
Yeah. So thanks a lot, Michael, and thanks a lot, Professor. So I think one thing we can collectively agree today is that if we had to make a drinking game today, it would be on the word trust. So we have heard this word a lot today, and I think I'll touch it once again. And I want to talk about few of the problems in supply chain. So I was talking during lunch with Mr. Puneet, also coming from the supply chain background. It's a crazy world right now in supply chain where we have a lot of problems, from semiconductor issue to the geopolitical issues of what's happening in the Eastern Europe, to our supply chains are more complex than ever, and the climate change, and all these issues are really big issues which needs addressing right away. So how we try to deal with this issue is usually we'll try to go the machine learning way, and that's where we'll have some really interesting conversations with the management. So I come from an entrepreneurship background where I know lack of money or less money is always a problem. And then when I moved to corporate, I realized that having a lot of money is always also a problem. So one of the biggest fear of the management always is that we'll end up spending €1 million on an algorithm or a tool, and in the end we'll just have an interesting number, a number which is not actionable, and that is where the problem lies. So during our conversations where we try to predict something as a data scientist, we go to the management and we'll explain our predictions. They will ask us that, okay, how did you predict this thing? And that's where these conversations start about the black box modeling. We'll start talking to them about post hoc explainability methods like LIME and CHAP, and that's exactly we start losing them, because they feel that we are not able to explain it well. There's lack of tribal knowledge in the models, and in the end it's just predictions. It's not a business recommendations which usually management wants. So talking about the use case that I worked in BMW and also with Professor Wicaksono, which is also the current state of most of the supply chains, where we don't have a lot of transparency about our suppliers, their state and their future state. So right now it will be more of a diagnostic analysis where it will be more reacting to situation rather than a proactive situation. And we won't know that how some of the external factors, like everybody knows that semiconductor issue is affecting the automotive, but do we know how much? Can we quantify the effect? Or can we know that how much maybe a flood can affect my particular supplier? And there's always this issue that we cannot simulate things. We cannot ask this what if counterfactual scenarios. So the ideal state always is that we would want to be ahead of the game. And that was our use case. And the heart of supply chain always is the suppliers. And what we wanted to do at BMW is that could we predict ahead of time which will be our worst suppliers, and not just predicting, but quantifying that, okay, how bad they will be, at what level. And then comes the counterfactual part that, okay, if there's a particular external factor in Miami, how my particular supplier is affected. And if I take a certain action, it could be that my material planners are involved, or my logistics quality specialists are involved, or my purchasing department is involved. What will be the effect then on the reduction of the backlogs of my suppliers, or in the reduction of the missing parts of my suppliers? So the approach that we took was, first we went to the experts. We wanted to gather their tribal knowledge. And that's where we utilized this multi-criteria decision-making method, specifically analytic hierarchy process, where we sat down with them, tried to identify the causal relationships, the causal methods, where we wanted to know that how external factors are affecting our supply chain and what are the rankings. And then we did the conventional way also, because particularly what I also wanted to do is do a comparison, that how maybe the traditional machine learning approaches are compared with the current method of escalating suppliers in BMW with the causal approach. So I wish I could show you our fancy dashboards, but it's right now in the stage of publishing. But what I can show you is this thing about the tribal knowledge graph, where we interviewed the experts and we got this beautiful tribal knowledge graph from as simple as how maybe a flu or an external event can affect our suppliers' backlogs, to something interesting like how a farmer harvest season can make us hiring of temporary workers, which could lead to some of the human errors and then eventually affecting my suppliers having the backlogs. So all this information we wanted to incorporate in our causal machine learning models. And not only that, what I was specifying is that we wanted to do this comparison, that can we compare what the experts feel about the current existing method of escalating suppliers versus the traditional machine learning methods with this causal AI methods. Now, first, I want to show you the transformation of where we were and now what capability we had. So before we had little to no capability to simulate things, to know that how an external event is affecting our suppliers, or we were more of the reactive stage, not a proactive stage. But now we have this capability, and we can give this thing to the management that, OK, this is the supplier, it can go down maybe in the next 2 to 3 weeks. And if we take a certain action, potentially we can make sure that the supplier will be fine. So now coming to the results part, and the more interesting part is we interviewed the research again in a more research way, specifically again analytic hierarchy process, where we did this analysis on a interesting demographic of data scientists, business analysts, people coming from Spartanburg, US, to Brazil, to India. And the results were really interesting, where causal AI was preferred by all of the experts. Now you may think that maybe are we comparing apples to oranges, where we are comparing the current descriptive approach to predictive analytics to causal AI. And I think this is exactly what the point we wanted to show is the capability of causal AI. One of the more interesting stats here you see is that if we combine all the criteria from business accuracy to stress test capability and explanation capability, and the time to recover, the traditional approach of traditional machine learning approach of escalating suppliers with the current approach was more or less the same, which could imply that the experts, they don't trust the machine learning models a lot. And if you see the numbers between the explainability part, they really struggle. So I think I'll touch one more time the LLM part, which has again been touched a lot today. And potentially of how I see LLMs being utilized in supply chain is identifying those particular external factors. Something really fascinating for me was this tribal knowledge graph that we derived from the experts. And when I used to sit down with these experts, try to interview them, initially they used to say that maybe I don't have that much of knowledge, maybe I cannot give you much. But at the end of those interviews, we used to have a really beautiful diagonal cyclic graph. And that also applies that maybe instead of starting from scratch, we can use something like a LLM capability. And if you see what I got from just a few prompts, was really close to the ground truth. So it took me around 40 hours to interview the experts in order to get that tribal knowledge graph. But just with a few prompts, I got something that was really close to the ground truth. Then the other approach always is to use this causal discovery algorithm. So here you see one thing is the ground truth that we already had by interviewing experts, and then is by using different algorithms like resist or PC algorithms to know what they are recommending, that how the potential a graph could look like. And now, again, comes the role of the experts, where they can come and testify. So in this particular graph, you see that the causal discovery algorithm is predicting that a missing part will cause a wrong delivery, whereas I think most of us can agree that it should always be the other way around. And that's again the part. Now, where also we can utilize it is at BMW, we do have this luxury of all these experts. How about companies which do not maybe have a lot of experts, or maybe small-sized companies? Because they are the ones who are more interested in this thing, that they'll always say that you have all these experts. In our case, we don't have these experts, and that's where we can utilize the capability of large language models and these causal algorithms to build more trust. And again, I want to stress on this point is that maybe the future of supply chain is just not better technology or more technology, but actually better trust. Lastly, maybe I just want to give a shout out to my team at BMW for helping us in this actionable path. Thanks a lot.
Oh, stay up here. Yeah. Great. Thank you very much to both of our speakers. That's just so interesting to me about the sheer breadth of applications that causality has. I mean, we've heard about finance earlier today, but now we're getting to things like even software design and, heavy industries. Just so neat to see all these applications. Are there any questions for either of our two speakers? Yes. Right here in the middle, the microphone is coming.
Hi, thank you so much. I learned quite a bit. I was wondering, in scenarios like supply chain, where some of the conditions might be very variable and unpredictable as to what could happen. For example, nobody estimated COVID is going to happen. Nobody estimated that Ukraine-Russia war is going to happen, and then how things are going to pan out. So how does this help us be more resilient or robust going into future, where, let's say, an unseen or unthought of thing happens, and then it creates this chain of events that end up creating, mess. So how are these models more resilient to that, or how are we going to be handling those?
So maybe I'll just reframe your question. So basically, you're asking about the black swan events, that how in those kind of scenarios. So again, a lot of things come related to trust part also. We saw, the supply chain was really damaged by these black swan events. So what we can do is that, yes, we can try to build those synthetic environments, maybe use different techniques, try to simulate the things. But I think that's where a role of a tribal expert becomes even more important. Is they playing around with those scenarios, we giving them the capability of playing around with those scenarios, and then they are the ones who try to decide that whether it can be plausible or not. Talking also about the trust is that, yes, it won't always be perfect, but I think that's where I'll go the more philosophical way of what OpenAI CEO said, that that ChatGPT is not perfect, but so are we. So it's, again, the trust factor that we have to give it to the experts, where they play around with all these simulation capabilities, and then we see how it goes.
So perhaps I want to add something. So that means I think what Ishansh already mentioned is that the role of human here is very important. Even like in the beginning of the process itself, Ishansh also mentioned that there is a lot of factors, possible factors, that somehow we need to, the factors could be like hundreds, even thousands. So we need to have the dialogue with the user or with people who are expert in the field. So that which factor that could be possibly are the influencing factors. So by using MCDM method like phagytopsis and so on, so we can kind of rank of these factors, and then see by using causal AI, we can then see the causalities, from these factors. So on the outcome, for example, like price or whatever what's the outcome is.
Great. And I think I saw one more question over here along the right wall.
Thank you. Actually, I want to understand more about your use cases. Like, you're working in supply chain domain right now. So, like, how do you actually operationalize your intelligence on the causal insights you got, and how do you solve the business problem on that?
Yeah, so I'll answer you how we do right now and also how we would like to do it in future. So right now what we do is that with all these insights, the final recommendation will be that who will be involved with dealing this kind of scenario, that it could be the purchasing department, it could be the logistics quality experts or the material planners, and we'll give them the intelligence that if the purchasing department is involved, potentially we'll see a reduction of, let's say, 20% in the backlogs of the suppliers. How I'll want to do it in future, and something that I'm working right now, is that to have this feedback loop with the suppliers itself. So we come to the suppliers, we tell them about these action points, and then take a feedback that if they took our suggestion, how effective it was and what they think of our suggestions. So that's how I'll want to go in the future.
Great. Maybe one more question here in the very front before we move on.
Sorry, just really fast. Very intriguing application of large language models there at the end. Could you just say a little bit more about how do you go from 40 hours of interviews to a few prompts with the large language model to construct the causal graph?
So basically what I'll repeat the question is that you are asking that it took me around 40 to 50 hours of interviewing the experts in order to get that tribal knowledge graph, and what could be the way of we can minimize that by using LLMs, right? So it's usually identifying those things, basic prompt engineering, and I mean, it's always better to give a initial overview that, okay, if we already have that, my missing parts will be related to the backlogs, and I want to know about some of the political issues, and I want to know about how the pandemic is affecting. Then it will come with a very general causal DAG graph. But then with prompt engineering, you can further ask that, can you tell me the more causal relationships that, okay, maybe a strike in Poland can lead my supplier backlogs to be affected. So it's just basic prompt engineering. And again, what was surprising for me is we think that these experts, they have a lot of knowledge, which they do, but it's not very unique in all the use cases. And what I got after just 3 prompts was very close to this ground truth. So what I am suggesting is an approach, instead of just starting from scratch with these experts, we can just use the LLM predictions or the causal discovery algorithms, and then the experts can further validate it or build onto that. You're welcome.
Great. I think another round of applause for both of our speakers here. Thank you very much.